Welcome, everybody, after a short break. For now, we have Sohan Maheshwar. Sorry if I pronounced your
That
surname
was good.
correctly. Sohan will tell us something about architecting cloud solutions from the sustainability perspective. What is really interesting for me, because I have the feeling that we don't think about such things, such factors during this designing our infrastructure, our solutions. So yeah, and everybody wants to live there in the, let's say, clean environment without any catastrophes, storms, and so on and so forth. So it's even more important for all of us. So yeah, basically, I think that one of the simplest questions. So what was the reason that you decided to prepare that presentation for us?
Well, like you said, Peter, I think now is the time. Tech is at the heart of everything that we do. And well, we need to save the environment. And I think with that comes many second order effects, which are also beneficial to us as businesses and to you as a business. And hence, I thought I'll share some of my learnings with the crowd today.
Great to hear. So the floor is yours, and keeping fingers crossed for you and for your presentation.
Yeah, thank you so much. Let me just share my screen. In the meanwhile, yeah, thank you so much, folks, for attending this. Next year, hopefully, we can do this in person. Yeah, you should be able to see my screen and also hear my audio well. So yeah, again, just as an introduction, my name is Sohan Maheshwar. I'm a senior dev advocate with AWS, Amazon Web Services, based out of Amsterdam. And today I'm here to talk to you about architecting for sustainability in the cloud. As I said earlier, now is the time, right? So scientists are saying there's only a limited window to actually make headway and limit global warming to only 1.5 degrees Celsius by 2050, which means we have to act now. So today, let's talk about how we can architect for sustainability and how we can actually make a difference. When we talk about sustainability, really it's a journey, right? It's not something that we turn a switch on and off and voila, we are sustainable. It really is about a journey, and to understand it, you have to start with sort of understanding what your impact and your carbon footprint is. Sustainability in general can be thought in three dimensions: in economic, social, and environmental dimensions. But today we're going to be talking from the tech aspect, how you're reducing your carbon footprint from your technology usage. Really, the focus of today is going to be on how you can architect and make small changes that have a big impact when it comes to sustainability. And in the end, we'll talk about how this idea of sustainability transformation really comes through, right? We have spoken a lot about digital transformation. So today we are going to talk about sustainable transformation. And well, why are we doing this? Well, one is we're saving the environment and saving the earth. It's a small reason. But also, as a business, sustainability drives business growth. It's as simple as that. In fact, in a recent study by Accenture, this was last year, they actually said companies at the intersection of digital tech and sustainability actually are 2.5 times more likely to outperform their peers. So not only are we being environmentally conscious and not only are we saving the environment, but you're also driving business growth. And really, it's about that as well. Just by shifting from a data center to a cloud, you're already being a little more sustainable. Some studies have shown that moving from a typical enterprise data center to an AWS cloud, for instance, shows up to 80% reduction in energy. And this is because how the cloud is fundamentally structured. In the cloud, everything is optimized for shared resources. So you have an AWS data center and availability zones, and all of those resources are being shared by different companies, different businesses, thereby being more sustainable than investing in your own enterprise or in your own data center. So step one, move to the cloud. But today we are, of course, talking about going one step further, which is architecting in the cloud for sustainability. Now, quick show of hands, how many people here are familiar with the shared responsibility model for security in AWS? And feel free to put things on the chat. I'm looking at the chat as well. Essentially, if you're not familiar, what it means is when it comes to security and compliance on AWS, it is a shared responsibility between AWS and you, the customer. So essentially, what we do is we take care of security of the cloud. So everything from physical security to making sure it isn't affected by natural disasters, to any updates and maintenance that's needed. While you as a customer, you are responsible for sustainability or security in the cloud itself. And we're using the same model when it comes to sustainability too. So you as a customer, you are responsible for sustainability in the cloud. And we as AWS, we are responsible for sustainability of the cloud. Right. So what does that mean? Well, as AWS, we take care of things like the servers, the cooling, making sure we recycle as much water as possible, making sure we reuse waste and recycle the waste, and at the same time, locally sourcing electricity supply, building materials, and things like that. And you as a customer, you're responsible for sustainability in the cloud. So data design, usage, architecture, storage, and all of that, which is what is the focus of today's talk. Before that, though, a very quick note on sustainability of the cloud. Some of y'all might know that in 2019, Amazon and Global Optimism co-founded this thing called the Climate Pledge. Now, this is a commitment to meet the Paris Agreement 10 years early. So actually get net zero carbon by the year 2040 instead of the originally agreed 2050, which was the Paris Agreement. And this is a path to 100% renewable energy by the year 2025. And Amazon's also pledged 2 billion to the Climate Pledge Fund. And the principles behind this, of course, are regular reporting, eliminating carbon, and also credible offsets. Now, specifically in AWS, we are doing few things to, again, increase and help us on this journey. Like I mentioned, in our data centers, all our water is, we use evaporative cooling, we recycle water, and we have on-site treatment for water as well. We're trying to use as much renewable energy to power these data centers as possible. The newer data centers that are being constructed incorporate the use of low carbon concrete. We use AWS Graviton 3 processors, which I will talk about in a bit, which use 60% less energy for the same performance and compared to other comparable instances. And of course, we have this data set called the ASDI, or the Amazon Sustainability Data Initiative. Now, this provides access to satellite climate data, climate models at no cost. So you can actually build really cool things, get very cool insights about this publicly available climate data. So just look up ASDI if you're interested in something like this. All right, so that is the sustainability of the cloud. Today, we're here to talk about architecting for sustainability and how you do that in the cloud, which is what I'm going to talk about now. So actually, let's define sustainability in the cloud. Now, how we define it is it's a continuous focused effort on energy reduction and efficiency across all the components of a workload. It's a fairly broad definition, of course, but some questions to really ask yourself are, what are your biggest challenges related to sustainability and how you're actually solving this? Now, given that we have so much experience at scale for the biggest customers, we actually came up with or learned some best practices for sustainability in these following areas, right? And I'm going to do a deep dive into each of them and then talk about how you can implement that in your business. So we are going to talk about region selection, user behavior, software and architecture, data, hardware, and development and deployment. And with each of these phases, we're going to talk a little bit about things you can do when you're actually building that goes towards sustainability. The first one, I think, is the simplest. How do you choose a region? Well, essentially, you want to choose a region and you want to implement your workloads based on two things: your business requirements and your sustainability goals. Typically, we do that based on things like only business requirements, which is Completely understandable. You might have latency, data sovereignty requirements, and all of that. But there are many cases where you can be flexible on some of these things, where you don't have latency requirements or you don't have data sovereignty issues. In that case, you can actually make a conscious decision to choose a region that meets your sustainability goals. For instance, there are different data centers in different parts of the world in AWS, which have renewable energy or renewable projects. So overall, there are 310 with 190 in North America, 88 in EMEA, and 32 in APAC. So if you have a requirement that's possibly closer to North America, choose one of them, and you're automatically being one step more towards being sustainable. So that's at a very high level, right? You're choosing your region. Let's talk actually about implementation and how to deal with user behavior patterns. When it comes to user behavior patterns, essentially you need to think about when, where, and how your customers actually are using their workloads, or how you as a customer, when, where, and how you use your workloads. Essentially, the idea is to scale with load, scale your infrastructure with user load, and again, eliminate things like unused assets. And there are different ways to do that based on the SLA or the service level agreements that you have with your customers. I'll give you an example. So, say you have an workload requirement which has a requirement for immediate failover, right? So, essentially, it's something that is mission critical, and you have something that needs to immediately fail over to something else. How do you optimize capacity while keeping your sustainability goals? So here's what it looks like. So you have an availability zone A, and hopefully you can see my screen. I don't know if you can see it. Yeah, there you go. You have an availability zone A and you have an availability zone B, right? Now you're running in two zones and you're reserving enough spare capacity to rapidly switch the load for resilience. The problem here is that your utilization is very low because only 50% of your availability zones in A and B are being utilized, and you need to keep availability zone C in case of an immediate failover because that is your requirement. So suppose availability zone A goes down, right? You move your workload to availability zone B, which is good, but you still have to keep availability zone C as an immediate failover. Now, this is not an optimal way of capacity because your utilization is actually quite poor. 100% of C is not being utilized just because you need that immediate failover. What you can do instead is something like this, where instead of having 50% utilization in two availability zones, you run 66 utilization, but in three availability zones. So this case, you're optimizing your capacity while meeting your sustainability goals because your utilization is actually really high. It's much higher than 50%. Suppose availability zone A goes down, this can happen where you move parts of your workload to B and C. So that way you're achieving an immediate failover while optimizing for utilization and for capacity. Now, that is the case of, say, when you had something mission critical, but what if you have a workload that is not mission critical and you don't need an immediate failover? Well, then you can actually optimize resilience while keeping your sustainability goals up. So in this case, you have AZ-A and you have AZ-B. You can actually use a cold capacity for failover, which increases your time to respond to a failover request. Yes, but again, this is not mission critical and you don't need an immediate failover. So you can provision cold capacity, and if something happens to availability zone A, you just move all of it to availability zone B, and your utilization is 100% on both times. You don't have all that extra capacity not being utilized in case there's a failover. So again, really review what your goals are and then architect accordingly. Sometimes it's good to negotiate SLAs or service level agreements which are impact friendly, which have sustainability impact. In some cases, this might even reduce cost for you as a business. So you're not only optimizing on cost, but you're also being sustainable. This can, of course, increase things like response time, but overall, your reduction in carbon usage is much lower. And if you have stakeholders that are convinced about, costs, well, often less resources means less cost. So just go for it. All right, so we spoke about user behavior. Let's talk a bit about how you can actually construct your software and achieve sustainability. And a lot of it comes down to optimizing your software and architecture for things like asynchronous and scheduled jobs. Really, it comes down to, again, removing or refactoring workload components which actually have very little or no use. And also identifying code that is expensive in terms of resources and expensive in how it actually utilizes your cloud resources. You can also take a look at access and storage patterns and try and reduce them throughout your usage. So again, let me give you quick examples. Here's how, if you draw a graph between capacity and time for your processing on your provision capacity, this we see this very often. What happens is we end up actually provisioning capacity for the peaks. As you can see here, these are the peaks, and we are provisioning a little above that just in case the peak is a little higher. But as you can see, the average is fairly low. Unfortunately, we end up, impact depends on your total provision capacity, which is this, and not the average. So if you can find a way to reduce these peaks like this, the amount of capacity that you provision also comes down. If you actually take a look very closely at the average between these two slides, it's exactly the same. It's just that the peaks have reduced, so you're actually provisioning a lot less. Now, of course, how do you do this? Well, there are a few things you can do. Quick question: does anyone know what this? Yeah, you might have seen these symbols somewhere on your terminal at some point of time. If anyone guessed a cron job or a cron tab to run at midnight every day, 5 points to Gryffindor. That's very good. So essentially, a cron job is something that you schedule at a certain time, and this way you can schedule something at midnight. We see many of our customers, such as yourself, do this often. Maybe you want to run an end of the day analytics or some sort of batch processing. You run a cron tab to run this at midnight every night. The thing is, this actually has lots of clock synchronized jobs that drive up these peak workloads. Imagine if all the businesses or all the people in this room did the exact same thing. Of course, cloud is optimized for shared resource, but if so many AWS customers use the same clock driven peak times, this drives up total capacity that's actually needed. So you can find ways to optimize this process as well. One way is actually to use queues and buffering, where you push an event into an event store and you pull an event which then goes into your business logic. So this way you're smoothing out those peaks and you're bringing those peaks down, and you're also buffering messages until resources are actually available. And that way you're bringing those peaks down, and that way your capacity also reduces. In another word, this is basically what is called jitter or offsets. So you're essentially doing sustainable scheduling, and there's no change to cost for you. It's just about adding few lines of code to add maybe a queue or some sort of push pull mechanism, which also increases performance possibly, but again may reduce your cost, or no change to cost, but definitely reduces overall impact in terms of carbon footprint. So there you go. All right, so we spoke about software patterns. Let's talk a little bit about hardware patterns now and what you can do. And essentially, I think this part is easy for me to explain because use only the minimum you need, right? So whatever least hardware that you actually need, don't over provision it, use the minimum you need. And you can actually do that by picking the right instance types and also using managed services. What a managed service essentially is typically a non-managed service. You take a database, you put it in the cloud, but you also have to like manage for scale and updates and security and things like that. And we actually see not so much optimal usage when it's not managed, because you tend to over provision or overcompensate at times. But when it's a completely managed service, these are some of the things that you don't have to worry about, and thereby you're using your resources more optimally and more efficient, right? And thereby using the right hardware as well. One way to do that is actually to shift to Graviton 2. Now, Graviton 2 is AWS specific, and it's a custom silicon ARM based processor on 64-bit cores. Just by shifting to Graviton 2 to any of these instances that are available, you can actually get a 40% better price performance and a reduction in the energy used as well. In fact, very recently, we also announced Graviton 3, which offers even more reduction in costs and energy use. So just switch to it. And we already have customers like Formula One, Epic Games, Discovery, Datadog, etc., who use these instant types for improving their performance. And if you want to get started, yeah, here's a GitHub link. Just go to that GitHub link that you see there. Um, Easy to get started. The thing with Graviton 2, all of these services are supported. So everything from the code bunch of services to compute, storage, Lambda, all of it, right? And all of the core services that you might use like EKS, ECS, Fargate, Lambda, all serverless, are supported with Graviton 2 as well. So check it out. So much for hardware patterns. Let's talk about data patterns in your workload. I think everyone talks about data nowadays, right? Like data is the new this or data is the new that. And every company and every business, such as yourself, is generating a lot of data. The thing is, when we do this, we actually don't pay too much attention to classifying this data based on how often you access it or how important it is. We are more focused towards building data warehouses, data lakes, scalable storage, all those sort of things, which is great. But there's so much more you can actually do with being optimal with all of that data. So you can add things like lifecycle policies for your data. You could even remove data that is not needed or is beyond a certain point based on your SLA. You can minimize data that's moved from one region to another. And you can only back up data when it's most impactful or impossible to actually recreate. So to give you an example of data classification and lifecycle, this is what it can look like. And again, this is more energy efficient. This leads to better storage and it reduces your costs. So why not, right? So say you have an Amazon S3 standard bucket. I'm pretty sure most of y'all are familiar with S3. You can actually write something like this, which transitions to deep archive after 30 days and expires it after a certain time frame as well. So it goes into a deep archive, thereby being a little more efficient, and you just remove that data if you don't need it beyond a certain time. Overall, though, I think it's important to add classification to all the data that you're generating. And this is one way to actually look at it. The thing is, Amazon S3 offers intelligent tiering that does this automatically to your data. So again, you don't have to necessarily, spend a lot of time doing this. Based on things like access time, AWS will do this for you. But it is a good practice to apply data classification policies to the data that you're generating. Just to give you an example, on the left, you will see hot data, right? So data that is accessed very frequently. Now, this can be stored in an S3 standard, right? Millisecond access, more than 3 availability zones. So it's there. But there's some data that is inactive, like the one that you see here. Now, this is warm data. So you can store it in one availability zone, still has millisecond access, but you're reducing your costs and your carbon footprint that way. And some archive data that you don't really need often, or you might need, say, once a month. The access time is longer, maybe a couple of hours, but it is stored in 3 availability zones again, for high availability. So this is one way of actually looking at classifying your data. You can also use technologies that best support your data access and storage patterns. There are different storage formats like Parquet, Arc, and Avro, and there are different data stores as well. again, using purpose-built databases always helps. You don't want to force fit your data to fit a database that you're familiar with. You'd rather choose a purpose-built database for that particular purpose, which again becomes more efficient, helps you reduce cost, lowers latency, while, of course, lowering your carbon footprint as well. I'll give you a very interesting example of how you can actually optimizing your now, again, every software out there generates a lot of log data. And
Sorry,
typically we,
sorry, Sohan, something is breaking your voice. So if you
oh,
log on that, so
okay. Can you hear me now?
yeah, yeah, I can hear you now.
Mm-hmm.
Oh,
Check, check, one, two, three.
yeah, seems that's
Yeah.
okay now.
Okay. Is it clear?
Yeah, it's clear.
Okay, okay. All right. Yeah. Yeah. So I was saying, I'm going to give you a story from an internal AWS service. We used to use all our logs archived to S3, and we essentially switched our compression from gzip to ZSTD or Z standard. And our compression ratio improved by 30% by just changing how we archive these logs, right? And our compression ratio improved from 1:7 for LZ4 to 1:15 when we moved to Z standard. And this actually reduced storage by approximately 1 exabyte, which, if I'm not mistaken, is about 1000 GB. I think or no, I think it's a billion GB or some crazy number like that. Lost track of the number of zeros there. Right. So essentially, just by changing the way we compress our logs, we actually reduce storage by that much. Think of all the cost and carbon footprint reductions you can achieve by taking a closer look at how you store logs. Yeah? Something as simple as that. And you can switch your compression algorithms and see which ones actually work for you. All right. The last best practice is in the area of development and deployment. It's not just about architecture and code. You want to actually do this across your entire software lifecycle, right? So when you're building out your software lifecycle, you need to add methods for rapid introduction of these practices. We are at DevOps Pro. So when you're thinking of the entire DevOps process, think of how you can add these processes into this life cycle to make things more sustainable. Because trust me, this is a new field, and this is something that all of us have just started talking about. So you will see a lot of improvements and a lot of enhancements in the coming years in this space. Think of how you can actually utilize your environments very well, uh, which is actually in a very sustainable way. Again, I'm going to give you from AWS, and you can relate it to something that you might have done earlier. We actually have an AWS SDK for JavaScript browser. And up until version 2, we actually included the packages every AWS service into that SDK. So with version 3, we actually introduced modular packages per service client. So if you wanted to use just SQS, S3, and Lambda, you could have only those packages in the SDK. So we got feedback from the community, we heard good things, and then we released it generally available. We actually saw the bundle size reduced by 75%, and then another further optimization reduced the install and publish size by 50%. Now you can just see the flame graphs there, and also maybe take a screenshot of that link, because there's a long blog post about how this actually helped. So again, you can relook at your build artifacts as well. I'm sure when you're building code, you generate build artifacts in the DevOps lifecycle. And sometimes there are needless packages or SDKs that you don't use, some dependencies that you've stopped using from previous projects. Really review that and see how you can optimize that at every space for, again, sustainability. How we suggest people take a look at this process is typically how we think how you would be looking at tech is going from concept to production with things like design, implementation, testing, staging on the way. And the best way to make sustainable part of your process is to do it with a well architected review in production. I'll talk about that in a while. And make that production workload a little more sustainable. And then we use a left shift, right? So we go from production and we become more sustainable in beta and staging, and then in the implementation, and then in the design. So again, we start off with the production and then left shift towards the start, and then you can actually build out processes from the start itself. Like I said, this is an ever evolving field. So I'm sure next year at the conference, I'll be telling you on how you can actually do some of these things more in depth as well. Just as a quick recap of the best practices I mentioned, when it comes to dev, you can do things like optimize your code, choosing faster languages and runtimes and compression algorithms, choose efficient algorithms, use data classification, reduce logging, so and so. And on the operation side, you want to utilize things higher, you want to automate as much, you want to deduplicate your data, and also choose your times and locations carefully. When you're doing all of this, you want to make sure that the savings are big enough to actually justify the work. If, you're not saving too much in terms of carbon footprint or cost, but you have like 4 person hours per week going into all of this, maybe it's not worth your effort, because overall, even that is not as sustainable. So really think of how these things work against each other. Like I said, sustainability really is a journey. And over the last 10 years, all of us have heard the word digital transformation, but now that's slowly changing into sustainability transformation. Especially companies that have clients have started talking about things like transforming sustainability and in the next coming decade. So really, it's about measuring, cleaning up, and decarbonizing all your products and operations. This is a little tricky because sometimes it's hard to understand what your impact is. When you look at things like metrics that you can take a look at today, you take a look at.
Sorry for interrupting again. Can you again do something with your microphone, because it's again
Okay. Not sure. Is this okay now?
we can't hear you unfortunately.
Check, check. Okay.
Oh, yeah.
Yeah.
It looks like something with your cable, because
Oh,
if you are touching, yeah.
okay. Check.
No, it's okay. No, it's okay. Yeah.
Okay, okay. Yeah, sorry about that, folks. Not sure what. Usually it's a very stable mic. I don't know what's happening today. Yeah, but Peter, if there's any problem, do let me know. Happy to repeat something. Yeah. So what I was saying again is here are some metrics that we look at day to day. We look at storage, utilization, data transfer, compute, and sometimes these work against each other, right? So how do you decide if you want to store things in many regions or if you want to transfer data from one region to another? Sometimes your data transfer costs will increase, but storage comes down, vice versa. Similarly, that works with storage and compute as well. Sometimes you want to compute as often as possible and reduce storage costs, or sometimes you want to store more data and compute less. Similarly, sustainability is a non-functional requirement, right? When you're looking at requirements like cost, quality of result, availability, response time, sustainability is part of that as well. It's another non-functional requirement that you have when you're talking to a business. And again, it can work against things like cost, availability, and response time. So really, the idea is to get sustainability as part of your goals on your day to day. All of us have daily stand ups, weekly catch ups, monthly business reviews. But let's be honest, how many of these meetings have you actually looked at a goal, which is sustainability? I'm guessing not too many. So now really is the time to add that angle or add that goal and metric of sustainability into our day-to-day conversations and look at it as a non-functional requirement. Overall, as a goal, you need to maximize utilization and you need to maximize CPU efficiency via software design, while you want to eliminate or minimize things like idle resources, data processing, and data storage. To actually measure, we often make the mistake of just looking at the number of resources used. And this is not necessarily the best way to take a look at it, because you can actually, have, I don't know, a reduction in the number of resources, or maybe your resources stay the same, but you have a reduction in your number of users. So that doesn't tell you too much, right? So a very accurate way of measuring is looking at resources per unit of work. So, say for instance, you're building out transport logistics, you can look at the number of CPU hours per vehicle mile, as opposed to just looking at the number of CPU hours. So that way you can normalize these sustainability KPIs or sustainability metrics to make them comparable with your goals and other metrics. Just to give you an example, I don't know if each of us know what our carbon emissions right now in the cloud are. Just last year at reInvent in December 2021, AWS launched the customer carbon footprint tool. So you can get details like what your carbon emissions are per region, per AWS service. You get a summary of what your carbon emissions are, and uh, it's part of your process. And really, you can take all of these learnings and establish fine grained and frequent KPIs at a team level. So, having these metrics along with other business metrics could be fed into your data lake, which can be fed into something like QuickSight to get like dashboards so that you look at sustainability goals on a weekly or day to day basis, as opposed to just having it as a buzzword on like a PowerPoint presentation somewhere. And really, it's also about every team owning their sustainability goals. As an architect or a dev, you should be designing for sustainability. And as someone in DevOps, you should be optimizing for efficiency. And as a senior leader or a team lead, you should be reporting things like carbon data and how your team has improved upon that goal. Remember, these are trends that also drive your business, so there is that much more incentive to actually look at all of this to be a differentiator in business as well. From an AWS point of view, we introduce sustainability as a new pillar in the well architected framework. Right? So essentially, if you're not familiar, there is a well-architected framework to review your workloads in the cloud, which looked at performance efficiency, security, reliability, cost optimization, and operational excellence. But now we added this new pillar of sustainability, just to make sure that your workloads are sustainable and you're answering the right questions and reviewing these processes. So as a quick summary of what we just spoke about, it is a journey. You start with identifying your carbon footprint all the way to architecting and then actually transforming sustainability. uh, I gave you all these best practices in terms of hardware patterns, data, software patterns, user behavior, and your deployment processes. And I told you on how to look at your KPIs and your metrics in your workload. Now again, why am I telling you all of this now? Well, like I said, this is super important because the world greenhouse gas emissions, or GHG, is 50 gigatons of carbon dioxide, right? It's the equivalent of 50 gigatons of carbon dioxide. When it comes to ICT, or information and communication tech, the estimate is fairly high. It might not seem as much in the grand scheme of things, but it is very high. But the thing here is, technology and IT is at the heart of everything that we do these days. So really, you and I have a chance to really make a difference right here. And the idea really is to think beyond IT on how we can think and act sustainably, add sustainability thing that we do. So this is almost like a call to action for all you builders out there. Uh, Start asking about questions about sustainability in your planning discussions, set goals, start having that conversation on social media, in your user groups, at your workplace, but also find areas where you can make a difference and also collect and share your learnings like how I'm doing today. uh, I think the time is now. So now is a good time as ever to get started with it. Anyway, I have 5 minutes for questions. I think I managed them quite well, but feel free to connect with me on LinkedIn, Twitter, whatever. It was my pleasure speaking to all of y'all. I hope to be at this conference next year, hopefully in person as well. Yeah, I have 5 minutes for questions. So if anyone has any.
Yeah,
Let's go.
first of all, thank you, Sohan, for your presentation. It was really inspiring for me. And as I said at the beginning, on our daily basis, we are not thinking about such things, but they are really important for us. So yeah, as you said, I would like to invite you, all of you, to think about that and to ask questions. Personally, I have one question to you, maybe one concern, let's say, because based on your presentation, we can think that thinking about sustainability is thinking also about the costs. And I don't know if we can um, equal the two things, but what I understood from your presentation, often when we are doing the design or doing redesigning the solution to think about sustainability, we are also have a possibility to reduce the cost. So from your perspective, how it looks from the practical side?
Yeah, yeah, absolutely right. And I'm going to show you this one particular slide again, which is this. Hopefully, you can see it.
Mhm.
Very often, you have non-functional requirements like availability, response time, and cost, and sustainability is one of them. And there may be times when cost works against sustainability, but in most cases, a reduction in cost and an improvement in sustainability or a reduction in carbon footprint goes hand in hand. I'll give you an example of cost of thing, right? So imagine moving your processing work from an end user device to your application. It might increase the cost of your application, but it actually lowers the demand to your end user devices. And maybe that old smartphone from last year won't be required to be upgraded because of your app. So that's sort of working against cost and carbon footprint, for instance. So these are some of the things that you have to actually consider as a business, right? What is your non-functional requirement? What are the service level agreements you have with your customer? And how can you add sustainability into that as well?
Yeah, exactly. And I can share some example from my life. I'm working mostly with the Azure, and we did for one of our customers, we did kind of cost optimization projects. We found one storage account with backups, and we noticed that it costs thousands of euro per month. So we we looked into there, and we noticed that there are backups from 2017, so it's quite
Mhm.
old. So I asked the customer, hey, do you need such old backups? And the customer said that no, we just have to have backups from last 30 days. So we applied a simple policy for removing blobs older than 30 days, and suddenly that storage costs I don't know, 200 or 5 or 300 euros per month. So
Yeah, yeah.
it's a high reduction of costs, and also reduction of that.
Of carbon usage, right? Exactly, right. And all it took like a small review meeting. Sometimes as a business, we are so focused on just like building that we tend to not have these data classification policies or time to review them. So I'm glad that you did that with your customer.
Yeah, exactly. So it can be a great possibility to do some review on the organization level and apply some policies globally, and not
Mhm.
only for that project. And also, I would like to share that thought that in business, everybody is busy with doing business on daily basis. So yeah, not thinking about planet.
Yeah.
What is that? Yeah, I just
Yeah.
want to make money. Yeah, so maybe
Yeah.
it could be quite good factor for your business owners that hey, maybe you can save. I don't know, 20% of costs or something like that. So for sure, then the business guys will be happy and will be open for our ideas. Yeah.
Mhm. Yeah, absolutely. Absolutely.
Okay, so I can't see any other questions on our chat. So thank you for your session. One thing, yeah, I see now. Can we get the slides for this talk? So do you have the possibilities to share that slides?
Yeah,
somewhere.
I can share the PDF perhaps with the organizers and they can put it out or something like that.
Yeah. So probably it will be available on your attendance, let's say, application. So thank you, Sohan, for your great presentation. It was really inspiring for everybody, I think. See you next year offline, maybe.
Yeah, yeah. Thank you so much, everyone. Thank you so much, Peter. And yeah, have a nice day.
Yeah, you too. And we will meet each other within 5 minutes on the last session on our